Hello everybody, welcome to the OpenValue meetup. Great that so many of you joined us tonight for two really nice talks, I think. First up we have Johan Janssen. He's quite a famous speaker actually, who spoke around the world at many conferences. Java 1 Rockstar Award winner, or was it Code 1?
Both.
Both even, so even better. Johan is going to talk about how and when to upgrade to Java 17. After his talk, we'll have a short break of about 10 minutes, and then we'll have our next talk by Kevin about Tekton CI CD. So have a lot of fun with Johan for now.
So yeah, welcome everyone. I hope you enjoyed your dinner. So my name is Johan Janssen. I work for ASML. Who doesn't know ASML? It's basically a big company, and probably the processor and maybe even the memory in your phone and in your laptop are created on machines from ASML. So if you're interested, let me know, but this talk is not about that. We're going to talk about Java upgrades. But first, maybe a very important question, because Java versions always a discussion topic. So I'm wondering what version you're using in your customer products. So not in your Hello World hobby project, but what do you do professionally? Is anyone already using Java 17 in professional products? Then you guys can do this talk. So let me know if you have something to add. Who's on 11? Okay, 8? Older than 8? Nice. That's already an improvement, because I gave this talk a couple of times where people were still on older versions than 8. So that's also a reason why I give this talk. I think for many people, there are various reasons why people aren't yet on a new version, but one of them is because it's sometimes seen as something which is a lot of work. And I try to explain that that's actually quite okay. And if you have any questions in between, please feel free to interrupt me. You don't have to wait until the end. I'm comfortable taking questions at any time. If you have questions later, feel free to also approach me. The presentation is based on a GitHub repository. I will also later show that one. That basically contains examples for all the changes that I've seen in the various Java versions, and also basically the errors that you will get and the fixes for those errors. So if you're actually upgrading to Java 17, that might be helpful. I didn't got all this information from Google. I actually upgraded many Java projects from 8 to 11, from 11 to 17, and various other versions. So I did this quite a lot of times, but still, of course, Google is your best friend, because if you encounter any issues, probably you will find the answer there. So this session is based on an experience for real projects, not only Hello World, but real production products, and also some feedback I got from other people who also upgraded their applications to Java 17. Why should you actually upgrade? Performance improvements. That's also always a bit of a topic. What's the performance improvement? Because it's not like that you can say to your manager, if we go to 17, then our application is 10% faster. You don't know that. It depends on your application, how you configure it and everything, but it should at least be faster than the older version. Security fixes, probably for most enterprises, also a good reason. I still hope that they stop supporting Java 8 with minor updates, because then hopefully some enterprises will move easier to 11 or 17. But I think for us developers, most important is that we can use cool new features like your records, the pattern matching. Now, for instance, you have the useful null pointers exception, where no longer you simply get like this line, there is a null pointer exception. Good luck finding out which object was null, but it actually says which object was null on that line. And I think nowadays, there are so many vacancies, you can choose where you work. Probably it's also a good idea as a company to make sure you have a bit of a current stack to keep and attract employees. So this shows basically how much the performance improved in this case for the committed memory. So let's see, the highest one is Java 16, then the purple one is Java 17, and the yellow one is Java 18. So in this case, it's faster. Of course, don't trust any statistics you haven't falsified yourself. It really depends on your use case, your app. Do you have like a web application or batch processing or whatever? So always, if you want to know this, simply run a proper performance test with the two different versions. So what are some reasons to not upgrade? can take quite some time. You have to update the various environments, not only your local machine, but also the build environment, production environment, etc. It can be quite a bit of work. Something else that a lot of people are saying is like, yeah, but if I upgrade to a version higher than 8, I have to use the Java module system, and that's complex, and I don't want to use that. Yeah, the good news is you don't have to use it, and actually like 99% of all projects don't use it. It's an optional feature. You don't have to explicitly configure your application to use it. Lately, it's actually getting a bit more traction because Spring is internally starting to make use of modules. Probably also to better support things like GraalVM and fast startup times, because it has some advantages to use modules, but it also adds some complexity. So I think like most applications will stay away from modules for now. The other case is some software is written and then you don't run it on your AWS cloud, but you have to run it on premise at a customer, or maybe in a AWS cloud from your customer. And maybe there's only an old version of Java running. And for that, there's actually quite a nice way to work around it, and that's called the multi-release jar, which is already in Java for quite a while, but it's relatively unknown. So I think it's a nice example to quickly show. So here you can see we have basically two student classes, one in the normal java.com folder structure and one in the java 17/com folder structure. But let's simply look at it in an IDE because that's probably nicer. So it's a pretty straightforward project. See, so we have here the Java 17 one. But first look at the normal student one. So this is a plain Java class. Probably looks familiar, else you wouldn't end up at a Java meetup, I guess. So some relatively standard stuff. We check, for instance, if there is a blank name with some little bit of code. So that's it, just a normal class. This runs on basically any version of Java. And then we have the Java 17 one, which is actually a record. So this is a new feature, it doesn't run on Java 8. And we have the string.isBlank method, which was also introduced in one of the more recent versions of Java. Both of them are basically in the same application, and we can call them also from the same application to get some information. So if we run this one, I basically run it in different Docker images with different versions of Java. So let's wait a second until this finishes. So here we see on Java 8, it uses the implementation Java class. On Java 11, it did the same. And on Java 17, it uses the record implementation. So automatically, based on which version of Java you're using, it picks the right version of your source code. Of course, you need a little bit of magic. I can quickly show that in the POM file for that. Let's see. So here we have some compiler stuff. So this is the normal compiler using Java 8 stuff. And then we have a Java 17 execution step. We specify which directory contains our Java 17 stuff. Java 17 directory, of course. Yeah, there is a little bit of configuration in the jar file. So it's not really complicated. It's relatively easy. You can copy paste it. You can even use more versions of Java. So if you, for instance, now run it on Java 18, it will use the Java 17 version, so the record version. So that's automatically running. I think it's quite a nice feature. If, for instance, you have performance improvements or special new methods that perform better in a newer version of Java, you can put them in a separate package, and then customers who run on a recent version of Java can make use of those performance improvements, and customers who are still on an old version of Java, they should simply upgrade, but they can still use the slower version. So this is actually quite an interesting feature to play around with. One thing that you should really keep in mind is that the public API, so the public methods that the class has, should be the same, because else if you call that class, you might get runtime issues. The build tool doesn't automatically validate it, at least last time I tried it with Maven, but the IDE, so IntelliJ in my case, it gives a nice warning, and from Java 17 you can also check it with this command to make sure that you have something that's working on all versions of Java. Of course, I wouldn't do this for like your entire code base because it's a maintenance hell basically. Then you have to duplicate all your classes. But for small improvements in certain areas, I think this is a nice trick to work around the different versions that your customers have. Something which, I'm quite a fan of Docker, but especially with upgrades like this, it makes life quite a bit easier. Before, if you had a build server, a lot of teams were using the same build server, so you had to either configure it with various versions of Java, and it was often configured by another department, so you first had to convince them to install Java 17 and to make sure that it was running both 8 and 17 and stuff like that. Nowadays, a lot of projects, they use built environments based on Docker images where the teams themselves can basically decide, okay, now I want to build it with 17 or at least try it without having to bother other teams. And that makes it, I think, a lot more flexible and easy to run it. And the same goes for production environments. If that's also Dockerized, it's simply a matter of making sure that you use the new images and prepare your code to run on a new version of Java. So the reasons for this session, I actually, in some of the companies I worked for, I had the discussion because one team, they estimated that an upgrade from then Java 8 to Java 11 would take them 3 months with, I think, almost the entire team. I was like, yeah, I mean, it's a challenge and you don't know upfront how much work it is. But like working with 8 people for 3 months on a Java upgrade is a ridiculous estimate. And I actually managed to fix that project in like a week in between other work. That was partly because I had some previous experience, but often these upgrades is also a matter of just getting started and try it out. It's difficult to estimate upfront because it depends a lot on what kind of frameworks you're using. For instance, if you use Spring Boot, you can simply update your parent POM and make sure you use the newest version, and then probably it runs fine on the latest version of Java. If you have a lot of dependencies that you manage yourself, then you need to make sure that all those dependencies are upgraded to a version that supports Java 17. So depends a bit per project, but I would say it's still something that's fairly well doable and not too much work. Actually, it's a good task to pick up because it involves a lot of time waiting on builds, and then you can drink coffee or something else. So a bit of a challenge, but I think not too much, and I will show you in this session as well. So I've seen in many projects that we had more or less the same challenges, more or less the same things we encountered. So I will discuss those. You might also encounter some project-specific things. I had some examples which I will also give later that were only occurring on like one project. That might happen, but a lot is basically common. I use Maven, but I mean, it works the same in Gradle. So let's go on the challenge together. For the ones who aren't familiar with the new release cadence, so Java 11 was the latest LTS until Java 17 came out. In between we had versions 12 until 16, which are major versions and they are production ready. So it's not like a beta version, you can use them in production, but nobody does. That's actually the case at this point in time. They also, most vendors only support them for like 6 months. So then you have to do a major upgrade every 6 months to keep up with security updates. While if you have an LTS version, you get minor upgrades for like years. So I haven't seen an enterprise so far who uses the 12 till 16 versions for production. But maybe like in the future, now the new major version will get some support for Project Loom, for instance. Maybe that will give a reason for projects to not only use LTS versions, but also other versions. But I mean, here you still see it's like 3 years between LTS versions. In the future, it will be only 2 years. So every 2 years, there will be a new LTS version which you can use. A question I often get is like, okay, this version is one discussion, like which version do I pick? Do I pick LTS or non-LTS? But then the next question is, which vendor am I going to pick? Because I mean, I'm old and getting gray. So when I was younger, it was the Oracle JDK that you picked. Or if you were stuck with WebSphere, you used the IBM JDK, and that was basically the choice you had. Nowadays, you have the Oracle JDK, you have OpenJDK, you have the Tamurin, you have a Microsoft OpenJDK, there is an Alibaba Dragonwell, there is a Liberica JDK, and a Submachine from SAP, and I missed probably a couple of them. And so which one do you pick of them? In theory, most are compatible because there's like a specification and all implement the same specification. So it's relatively easy to switch between them. But we will see later that there are some minor differences in some of the builds. And what for me is the most important difference is how long do they support things? Like for instance, Azul, as far as I know, are the only ones who give longer support to non-LTS versions. So if you want to run non-LTS versions, might be a good idea to look at Azul. We want to run, some of the companies I work for, we wanted to run Docker images. Some vendors support Docker images, other vendors don't support Docker images, or they support Docker images with only a JDK and we wanted to have a JRE. So I would first look at like what do you want to have, and then see which vendor fits best. And in the end, it's relatively easy to switch. So we started, for instance, with Adopt OpenJDK because they had everything we needed. There was a large community behind it. But at one point in time, Adopt OpenJDK, it became Adoptium and a Timurin. And then they decided we no longer create JREs. You have to use JLink and everything to create them. There are some benefits, of course, to that. But we wanted to have JRE Docker images and not do the building ourselves. So we decided to go to Liberica JDK, which still provided them, and we could quite easily swap between those two. And so unless you use specific features, it shouldn't be too hard to switch them. And if we upgrade, what do we actually need to upgrade? So we're running on Java, and on top of Java, we have some application code, I guess. And unless you wrote the entire application yourself, you probably also have some dependencies. And yeah, then Java removes something, and you need to fix something either in your application code or in your dependencies. And actually, like some people say, a lazy developer is a smart developer. If you wait, your dependencies are already fixed for you. So you simply upgrade to the latest version of your dependency and you're good to go. Often that it depends a bit, of course, if your dependency is under active development or if it's some obscure dependency. But if they're under active development, often already during beta releases of Java, they will upgrade the dependencies and fix the issues. So when I did upgrades, yeah.
Is there actually any reason why you can't just use your own dependencies? Like, is there other cases where it will not work?
That's a good question. Why can't you use the older version of your dependencies? For instance, if Java removed a method and the old version of your dependency is using that method, and we will later see that Java is also, it has internal code and they want to hide it away more and more. The more they hide it away, the more the frameworks that depend on it and the libraries, they will break. So that's basically the main reason. Yeah, good question. And actually, when I talk about deleting, often it's not really deleting because Java in general deprecates stuff. So basically they mark it for removal. This is an example, JuxB. So in 9 it was deprecated, you get warnings. If you then already fix it and simply use the correct solution, then by the time it's actually removed, I mean, you have already solved your issue. And that's in many cases the way it works. Now what can be removed? It can actually be anything related to Java. So it's not only like methods, it can be things like certificates or complete applications, even like Java Mission Control. Who has used Java Mission Control already? Not many people. I can really recommend it. So you have Java Mission Control and Java Flight Recorder, tools basically to profile your application and get better insights into your application. Nowadays they're for free. Before they were part of the JDK. Now you need to install them manually, so we will see later, but that's relatively easy. Yeah.
One caveat that I noticed, maybe they fixed it since then, probably not, because the flight recorder is from Oracle. If you use the OpenJ9 JVM instead of the hotspot one, it generates the data. The dump format is not compatible with the mission control and flight recorder. So if you want to use mission control and the flight recorder, you need to use the hotspot.
That's a good one. Yeah, you indeed, where you run mission control and the application you're analyzing also need to run on the same type of JVM, the same version. So both need to run on 8 or something like that. So there are indeed some restrictions, but this tool is actually capable of analyzing even production environments with only a low percentage of overhead, like between 1 and 3%, because it's completely built into the JVM basically. And that's really awesome. Yeah.
There's also another caveat that the flight recorder is a commercial license. So if you run it in production, you have to pay a license to Oracle.
That was a caveat. It's no longer the case. They open sourced it actually. So nowadays you can use Flight Recorder for free on production because indeed in the past you had to pay for it, but it's open source. And I think it also changed the name. Like before it was, I think, Java Flight Recorder. Now it's like JDK Flight Recorder or something like that. But you can at least now use it for free on any environment. So that's, I think, a nice improvement.
Don't use the Oracle license JVM. Make sure you use OpenJDK. Otherwise, Oracle might still get you with licensing fees.
Yeah. But I think by now everyone is using another JVM than the Oracle one. So yeah, some more information. I found the Java Almanac.io. So if you want to have more information on what is being added or removed or planned to be deprecated on basically method level, you can see in the Java Almanac. It's probably not something you want to completely read through, but I sometimes had an issue when I upgraded, something didn't work and I was like, hey, what happens here? And then I found in the Almanac that actually that method was removed that we were calling. If you have trouble sleeping, probably this is also a nice resource. So there are some more ways. Let's simply look from our browser. That's probably easier.
To fall asleep or to stay awake?
Yeah, depends on how nerdy you are, probably. I would fall asleep, let's say it that way. So this is basically the repository that I created. So it contains a lot of information on the various versions and what issues you can have, example errors and fixes. So that might be helpful. You have the Java Almanac. You have a different version from Fuji, which contains the same information, but with a bit of a different look and feel. You have the release notes from OpenJDK. So this is more high level on the Java enhancement proposals, the JEP level, what's being added or removed. You have some Oracle release notes, which are a bit high over, but contain a bit more details, like for instance, what smaller things are deprecated, and I think also some, here are some encryption algorithms and stuff like that. So this contains a little bit more detail. Again, I found this basically out when I was preparing the presentation. Most of them I didn't use up front, but it's nice if you really want to prepare up front and want to see like, hey, is everything I use still supported? You could have a look at this. In theory, for me, it's basically I do the upgrade and I see what breaks and then I fix it. Yeah, we've seen that. So yeah, when you do the upgrade, normally it's not like months of work, but it's probably a couple of days, and you probably still have a project which maybe have bugs or production issues that you need to resolve. So probably you want to run multiple JDKs or JREs at the same time. So there are some different ways to do that. You can of course replace them every time, but that's a bit annoying. You can change the Java home to point to another version, use something like SDKmon. There's also a feature in Maven tool change. Who's using Maven here? Yeah, most people, like in the rest of the world, I guess. So then you can specify in one file what JDKs you have installed on your system. And then from your POM file, you can reference one of them and change that whenever you want. So that's also a nice way to work with different versions of the JDK on one machine. And then there is, of course, Docker, which I quite like. But of course, it has a bit of a longer feedback loop because you have to build the image and then wait for the response. But I had some really weird issues. I once was upgrading a project and it gave really weird errors. I completely didn't understand what was going wrong. And after a while, I decided like, okay, let's run it in a plain Docker image. Maybe it's something in my configuration on my system because you use your laptop for a couple of years and after a time it gets screwed up. So I ran it in Docker and it worked perfectly. And then I was still puzzled, like, but why? And then I found out it was some weird thing that didn't work on my Windows laptop, and Docker images were in Linux and there it worked perfectly. So basically it was working because the rest of the team where I did it for, they didn't use any Windows laptop, so I could simply push it and I was done. So Docker is a nice way to make sure that you have a clean environment and to try out some things. And even who's worked with Docker here? I think the majority, even if you haven't done much with it, doing simple builds is relatively easy. You write down something like this in a Docker file, basically replace your project with whatever name your directory has, and you can run your examples in a Docker image with this command, docker build -t java upgrade. The most puzzling thing for me, I think, when I started with Docker many years ago, was the stupid dot at the end. You think it's the end of the line, so you omit it. But it's actually the context. You have to specify that you want to build your current directory. So you have to specify the dot. And then when you roll out a new version, you probably start with fixing your issues on your local machine, then run it on the build server, and then run it on the production environments in your other environments. Sometimes, so I did it for some teams where I wasn't really involved in. So it took quite some time to set up their configuration, so I sometimes did it as well on the build server, but then it's again a bit of a long feedback loop to fix things. Needle in a haystack. So if you upgrade to Java, you can go from 8 to 17 or even 18, which is already available at once. But then if you get an error, it might be quite difficult to trace what caused the error. Some errors, if you Google them, it's quickly clear. But for some errors, it's easier if you know which version of Java it caused. So sometimes it might be a good idea to go from like 8 to 11 and then from 11 to 17 if you have really difficult issues. I have to say I'm a bit lazy, so I mostly go at once and then try to fix it. And if it really breaks, I could go to a lower version of Java. But most of the time you can relatively easy find what's going wrong, especially after you have done a couple of upgrades. Ingredients. So yeah, make sure that you have an IDE with proper support for the latest version of Java. Actually, it doesn't need to have support for like the new language features, because first, we don't use them. We only make sure that it compiles with the new version of Java. But also make sure that you upgrade your Maven compiler or your in Gradle, the Gradle compiler, and all the plugins to make sure that they run on the latest version of Java and not on some older version of Java, because then probably on the build server you will find out that it still breaks. Yeah, for Maven, since Java 9, it's relatively easy. You only have to configure the release version and then you're good to go. Actually, I think the most challenging part of all the upgrades I did this far is upgrading the dependencies. Upgrading Java itself is really easy, but making sure your dependencies run on the new version of Java is often quite a challenge, especially if you have some projects where I've seen projects that used Groovy and Java together with, I don't know, 30 libraries. They're all glued together, so if you change one, basically all the rest breaks, and if you change all of them to the latest version, it also breaks. So you somehow have to figure out which version works with which version of which dependency. So I always advise, not only if you do a Java upgrade, try to keep up to date with your dependencies, because I mean it's good for security, you can use the latest features, and a Java upgrade will be a lot easier. One thing a lot of people forget is that you now have really nice tools like Renovate, who you can run, and it automatically scans your code base, and if there is a new version for your dependency, you get a pull request, and you only have to click merge, and then you have the latest version of that dependency in your POM. But there is a tricky thing if the artifact or group names change. So if your artifact is forked or whatever, and they change the naming, then you don't automatically get the new version. We will see an example of that later as well. So if you want to see which versions of Java you're using and to which ones you can update, there are many options. Like this simply displays the latest version. I think you can even use it, the versions plugin, to automatically upgrade it. But like I said, you can also use tools like Renovate to do these upgrades. There is a lot of stuff available nowadays. And it's, I think, a good practice to make sure that you, on a regular basis, like maybe once per sprint or once per month, make sure that your dependencies are of the latest version. So this is actually an example where the package names changed. So probably you all know Java EE. Nowadays it's called Jakarta EE. It's no longer part of Oracle. But they changed the name basically. So it's no longer Java X, but it's now Jakarta. So if I simply would upgrade to the latest version of the JAX-B API, I would be stuck on a version from 2018. So you have to make sure that you not only change the versions, but also check if there is maybe new packages available with the same functionality. And therefore, there is another plugin, like everything in Java, there is a plugin or some tool available. So there is a Maven and a Gradle plugin, which basically has like a blacklist of all the version or all the names that are no longer being maintained and the replacements for it. And you can easily run it in your build to get notifications. When I do these upgrades, I often advise to really do it step by step. Don't try to get like everything working at once, because then you might be stuck after like a couple of days, like, yeah, I'm 80% done, and you have to convince your management to spend another week on it. And everyone knows what that 80% done means. You still have 90% to do. And so then it's hard to convince people. But if you can say like, okay, the entire project, I can compile it now. I now need to fix my unit tests. Yeah, then people can get a better feeling of how much work it actually still is. Of course, it's a little bit vague, but it's more clear than saying that it's 80% done. So try to do it in a structured approach, because for me, I think The upgrades aren't that much a technical challenge. Most of the cases I've seen, it's more an organizational challenge, convincing people that you actually get time to do them. And then when you're lucky, you get a really nice pizza. But let's look at some details of what's actually being removed in various versions of Java. So if you look at JavaFX, who's still using JavaFX? No one. For the ones who might still want to use it in the future, it's no longer part of the JDK. However, you can basically get the separate downloads for it or a separate Maven dependency. And one thing you might notice here, there are still JDKs that include JavaFX. Like I mentioned, all the vendors, they create a JDK and maybe a JRE with the same specification, but they can add extras. And one of those extras can be a JavaFX, or in this case, OpenJFX. So for instance, Liberica has the full JDK. It contains all kinds of extras, including OpenJFX. So if you really want to do JavaFX and you don't want to use the Gluon one or the Maven dependency, you could use that one. Another interesting one, which a former colleague of mine detected. So previously in the JDK, you had a small set of fonts. It was only like, I think 6 fonts or something like that. But I don't know, maybe to save disk space or something like that, they decided to remove them. So there are no longer any fonts on the JDK. In most cases, that doesn't matter because the next place your JDK looks is your operating system. And often your operating system has way more fonts than your JDK. However, if you use Docker images, which is quite popular nowadays, you have, for instance, Alpine Docker images who are really small, and they also don't have any fonts in them. So then basically, yeah, fonts cannot be found and you get really weird errors. For instance, if you use Apache Poi can be used to work with the Word and Excel documents and stuff like that. They also need a font and it will crash with vague errors if you don't have them. Easy solution is basically to install the fonts on your operating system or in your Docker image or whatever. Yeah, so Java Mission Control has been removed, but as mentioned, you can now download it separately. I think, yeah, Adopt OpenJDK also releases a build, and there are some more vendors who release builds of this one. I think the biggest change for most people is the removal of Java EE and Corba. I don't hope Corba will be a challenge for you, because then it's time to look for another job. But I think the Java EE change has a lot of impact because a lot of projects were using them. Maybe not full Java EE, but I think most projects use something like JAX-B. And then actually you have to change your imports from JavaX to Jakarta, and you need to add the dependencies. I had a discussion about this in the past, which I think was a good discussion. Like, you could still stick to the JavaX ones, the old ones, and add those dependencies, because actually Jakarta EE, it's a nice initiative, but not much happened in the last couple of years. I think it's gaining a bit more traction now, but in the past it was basically the same as the JavaX one. So some projects, they simply added the JavaX dependencies and didn't change their imports. That's also a possibility, but yeah, if then Jakarta offers new features, security fixes and things like that in the future, you then have to do the change anyway. So yeah, it's basically up to you. Yeah, if we look at it, it's relatively easy. The different modules all have basically now dependencies available, artifacts available that you can use. For JAX-B and JAX-WS, you need 2 dependencies, one for the API, one for the implementation. And for Corba, there is no replacement, but you can still use some Glassfish stuff if you're stuck with it. I think this was for most of the migrations I did. Probably most of the work finding out which of these we were using and making sure the imports were resolved and adding the right dependencies. Then Java 15, removal of the Nashorn JavaScript engine. It's also, I always thought nobody would be using this. I saw it in conference talks, like on Java 1, there were countless sessions about it, but I never saw it in practice. And any one of you use it in practice? In a real project or hobby?
No, real project.
Nice.
No.
Okay, that's nice. Okay, but it's not interesting. Let's call it that way. So actually, when I did for a company a lot of upgrades, at one point I got a Nashorn exception. I was like, "What's this?" And then I found out they were actually using Nashorn somewhere. And yeah, well, I don't know why you still would want to use it. If you want to use it, you can simply add the dependency again. So it's no longer part of the JDK, but yeah, add a dependency and you can still go. And then we come to the part where you had a good question about, like, hey, why should I even care about upgrading to a new version of Java? And isn't it backwards compatible? Can't I simply, it was more about the dependencies. Can't I simply use old dependencies? And this is one of the cases where, yeah, at least a few dependencies broke because JDK had some internals, like really low level code, and it was never meant to be used by us mortal developers, only by the holy JDK developers, but there was never a way for them to hide it away. Until like they introduced the module system with Java 9, then they could hide it away, but they opted not to do it at that point in time because it would break any application basically, everything would break. But now they're step by step making it more and more difficult to use those parts. So all the tools and frameworks that use these internals, they will have to be changed. And to give concrete examples, for instance, Lombok, probably used by many of you, it breaks because it uses those internals. But as soon as a new version is released, they often release a fix for that and make sure that it works again. Other examples that I've seen are testing tools like mocking frameworks, who also use quite some of the internals. But also there, I think for Mockito, I once filed an issue and it was resolved within a couple of days. So even before the official Java 17 release, they had already a release that fixed it. So if you're lazy and simply wait until new versions of the dependencies are released, it's often already fixed. Yeah, so that's explained here. Make sure you use a new version of Lombok above 1.18.20 if you are in Java 17, and basically upgrade all your dependencies. Yes?
There's something about reflection as well. Now, specific types of reflection are no longer allowed.
Yeah, I think some of the is some parts of reflection no longer allowed is the question. Yeah, indeed. I think parts of the reflection are in the internals of the JDK, so you can no longer use them. But for, I think, almost any or even all of them have replacements created by the JDK developers, which are basically higher level APIs, which you should now use. So in general, it should be relatively easy to rewrite your code. And I have to say, I mostly see it in dependencies breaking. I only saw it once in code we wrote ourselves that it broke. It was some unit tests, which I think also used reflection. And it broke, but I could easily rewrite it without using reflection. And I think that was the only part where I had to change my own code because of these internal things that are getting more and more difficult to use.
Yeah, I remember like a Spring-based project starting up on JDK 11 and then saying like using illegal for reflection-based stuff, this will be removed later, something like that.
Yeah, indeed, Spring uses quite some reflection, and I think but Spring regularly updates to the latest version of Java. So if you are on the latest version of Spring, normally you don't have any issues with it. And there is actually also a workaround, which, yeah, I show it, but I find it a bit dirty. I mean, people put a lock on the door and you basically remove the lock. So in your compiler, you can specify some arguments. Basically, this is all closed, and now you say, I want to open it up. And I don't use modules, that's why it's all unnamed, the module where it's opened up to. But this way, you can basically still use those features. But like I mentioned, I wouldn't do it. Another one, which is even dirtier, is basically start Java with the -- illegal access flag. Then basically it does the same as the slide before, but basically opens up everything at once. Yeah, it's nice maybe for now, but as we will see, it will get you into trouble later. Yeah, maybe it's good to show, like for Java 16 Lombok, you get errors like this, like cannot access class because module blah 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 does not export to some unnamed module. So this basically indicates you're trying to use one of the internals, which you shouldn't use. And then, yeah, basically upgrade your dependency, fixes it in most cases. So Java 17, a couple of things have been removed. Who's still using applets? No one. I once gave this session and I was laughing about it, and then someone was like, yeah, but we're still using applets on really old browsers. So apparently some people are still using it. It's deprecated, so it might be removed in the future, so prepare yourself. AOT and JIT compiler, the experimental ones, they have been removed, but that's basically what GraalVM is doing, more or less. So if you're interested in things like that, basically use GraalVM. And we see another encapsulate JDK internals, which I will talk about more next. And then there's the security manager. Who's using the security manager? Some people use the security manager, but I've used it in one project. It's quite a nice way to basically make sure that your JDK cannot do anything on your operating system, and then you enable some flags, and then it can only do the things that you really want, and all the rest is hidden away. So it's actually quite a nice way to make sure your JDK doesn't mess around. Probably a good idea from a security perspective, but somehow basically no company is using it. So about strongly encapsulate JDK internals. I explained before, you could use the -- legal access modifier in Java 16. Unfortunately, in Java 17, that's blocked as well. So they make it more and more difficult. You get an exception like the one below. So again, upgrade your dependencies. Make sure you use JDK APIs that are still accessible. And unfortunately, you can still use the -- add opens, which we saw before in, for instance, Surefire or your compiler. So that option is still available, but I would bet my monthly salary on it that in one of the next versions of Java, this one's probably also closed. So then you really need to do something. So I think it's good to be prepared and only use the features that the JDK developers actually want you to use. To give some examples of what actually went wrong when I migrated to Java 17. For instance, if you have enum and it has a field with a method in it, and you try to mock it with Mockito this way, you get a quite weird error underlying could not modify all classes. So basically this is what I encountered. I contacted the Mockito developers and they immediately provided a fix. So if you ever encounter something like that, upgrade to the latest version, and if that doesn't fix it, simply contact the maintainers. In most cases they are happy to help you with issues like this. Kotlin was another one which wasn't ready for Java 17. I got a really good error. I really can compliment Kotlin for that. Now on JVM target version 17. I mean, everyone gets that probably. But that's fixed by now as well. More or less the same as for Gradle. So I wasn't really that aware of it in the past, but Gradle is a bit more tied to the version of Java you're using. So actually I could use Maven already to build Java 17 projects with early access releases of the JDK, but Gradle didn't run on Java 17 until I think it was nearly released or even released. So they have a bit of a tighter dependency. So if you want to play around with early access versions, probably better to stick with Maven. And I got this really nice error message, which I encountered in quite some places. For instance, Jacopo gave the same error. Anyone know what the error means?
Class version for Java 17, right?
Exactly. One more further. It's the class file major version 61 is used for Java 17. So it's a bit confusing because maybe you would expect something like Java 17, but there are multiple versions of those major versions that are not in sync basically with the Java versions. But for instance, Java, if you get the error but then with 60 instead of 61, that basically means Java 16 is not supported. So basically again it means you need to upgrade your dependencies and then you're good to go. This was at first quite puzzling for me. I really had no idea what this was, but then Google is your best friend, basically. So then we're done. So maybe also good to show a small example from the repository. So for instance, I created examples for each Java version. It's on the screen. Yeah. And I have a simple Mockito example, one that's broken and one that's fixed. It's in this case, it's really simple. This one uses Mockito 3.11, and this one uses 3.11.2. So really exciting example. Let's see if we build that one. And so if we build this in Java 11, everything will work because I mean, it was still open, the JDK internals weren't hidden away, so both the broken example and the fixed example, they both run perfectly. Let's see, where is it? Yeah, so we see 3 times success. If we do the same with Java 17, I did some extra commands for Docker to make sure that caching and stuff works properly, but that's not really mandatory, so you could also use it in a bit simpler way, but the more difficult commands are also in the README. Let's see, where is it? So here we see that on Java 17, when I run it on a Docker image with Java 17, the broken one fails because the internals are now hidden away, and the other one, it's fixed because the new dependency doesn't use those internals. So I basically created examples for most of the stuff you see in here, where you can play around with if you want to. So now we're basically there. Now we can use all those cool new features like pattern matching and records, where basically we did all this work for. Like I mentioned, amount of work, I would say in general, like, yeah, if you spend a week, most of the time it's done. Like 1 man week, you should be able to upgrade your application sometimes quicker. A lot of time what I see is spent in builds. So yeah, is that actually work? You could do something in between as well. But yeah, drinking coffee is also nice. And so it's not too long. And if you look at from 8 to 11, that was actually for most projects a bit more work. If I look from 11 to 17, it's actually a lot easier. Most of the projects I only needed to upgrade the test dependencies, and then it was good to go. While we used all kinds of weird frameworks and libraries, but they still worked properly on Java 17, even though they weren't upgraded nicely, which I always advise, but not everyone does that. So I would say from 11 to 17, it should be a matter of days, basically. Like I mentioned, try to do it incremental, but also like we can keep blaming management for not giving us time to do this. But in the end, I mean, it's also for us. We want to use those cool new features. So I often did it on like a Friday afternoon when my hours were finished or nearly finished. I started with an upgrade, tried to get stuff compiling, saw a bit what went wrong, and then I could give like a rough estimate, like, yeah, give me another couple of days and I probably can fix it. And then management is often like, yeah, okay. But if you say up front, I have no idea what goes wrong and it cost me like 3 months, then probably they won't give you the time for it. So yeah, also take your own responsibility in that one. And make sure you start upgrading now. Any questions?
So let's first hear it for Johan. Before we go to the questions, first a small token of our gratitude.
Thanks.
So hope you enjoyed this beer.
Thank you.
Something to bite. And does anyone have a question that they would like to ask to Johan? Please, Johan.
Do you have any experience with the Cassandra client?
Can you repeat?
Do I have any experience with the Cassandra client? Not yet. I know that, for instance, with Spark indeed, it's not yet compatible with Java 17. So there are indeed some frameworks who don't support Java 17 yet. For Spark, I know it's coming in the next release. So I expect most bigger tools and frameworks should be solved this year, but it's indeed some corner cases where you still can't upgrade.
I don't see any other questions at the moment. I do have a question for you.
There's one hand.
Oh, sorry, Volker, please.
That's okay. Earlier on, I forgot the name. You explained how you can build software to be with multiple implementations. Right?
Multi-release jar. Yeah, so to build different versions.
How well does that work for libraries? If you want to develop a library, and when distributed to some customers have 8, some customers 11.
Yeah, it's a good question. If you build a library, how good does it work? I think it works pretty well, but it can quickly become a nightmare to maintain. Because the more versions you need to support, the more of these things you will have. You need to test all the various deviations. So yeah, I think it's a nice idea if you keep it like small to just improve certain features and not to make it too big, because then, yeah, I think you will have a task, full-time task to keep everything in sync, basically. But I think it's ideal for library developers because they often support like really old versions because they don't want to break compatibility. And this way they can actually support them, but also support people with cool new features on newer versions, yeah.
Okay.
So I learned a few things from your talk. A tool like Renovate sounded actually really interesting. And you also mentioned everybody should by now have moved away from Oracle JDK. So I think there's a lot to tell maybe about that. Why would you want to move away? I actually do know the answer, to be honest. But and there are some alternatives. You're using Liberica, and as you mentioned, Jasul, can you talk a little bit about that?
Yeah, so I don't say per se that you need to move away, but what I noticed that where in the past everyone was basically using the Oracle JDK because that was the only one, and then we got like the free alternatives, adopt OpenJDK, OpenJDK, most people I think migrated to those, and now Oracle released some version which is free again, but it again is with really vague licenses. So I think if you only use the JDK, it's free, but if you use it in combination with other Oracle licenses, you need to pay or something like that.
I think actually since, if I'm not mistaken, somewhere in 2019, if you're using Oracle JDK on production, you actually need to pay, a subscription cost or license cost. I'm not sure which one of them.
Yeah, that changed like last year. So they actually have a free version now available, but with a lot of licensing
Yeah,
and
you have to keep
and terms.
updating to the latest version as well, I think, if you use an older version. So it's difficult.
I think it's difficult, and all people already moved away, and there's not really, I think, a reason to migrate back. So I don't expect that many people will use it. Maybe in bigger enterprise software for really, if you have like the commercial stack from Oracle with SOA Suite and stuff like that, maybe then it's interesting. But most projects I see, they use something else. And
probably you have a license for Oracle JDK if you use an Oracle product like SOA Suite, I guess. But it's a different topic.
And then for other vendors, like I mentioned, it's a difficult pick. I would really look at what features do you want and which vendor offers which features. Because I can't really give a good preference to one or the other. We chose Adopt OpenJDK because it had all the features, and we like that it's more like an open community. On the other hand, I now see that they are struggling quite a bit to deliver new versions. So it takes them weeks to deliver a new version. And if you want to use every major version, so also not the non-LTS versions, they come out every 6 months. If you then need to wait like 3 weeks, then basically, it isn't that quick anymore. So it's a bit, I guess, personal preference. In the end, doesn't matter too much because you can quite easily switch between them.
All right, so let me check if there's a question online. No, there's not. Anyone else? Question? Jago?
What's your favorite new feature from in Java?
The favorite new feature in Java.
And indeed, the favorite new feature, I think I would say that the most useful is the null pointer exception, which is now better explained. It's maybe not really like the cool new feature, but if I look back at how many times I have to debug and find out which object was nil, I think that could have saved me a lot of time. But things like records are also really cool features. But I think that sometimes has a bit of a marketing challenge, because first I think it was marketed a bit as it will replace Lombok, which almost everybody is using. But basically we now found out that it doesn't really completely replace Lombok, but because it's only for immutable solutions. So for instance, if you use JPA entities, you cannot use it. So I think it's still a useful feature, but for certain cases.
So I can recommend watching the video about JDK 17 from Simon Ritter that he gave at our meetup a few months ago, where he goes all out about the new features of JDK 17. All right, so thank you very much. We have a short break, 10 minutes, and then next up we have Kevin. Thank you very much.
Thank you.
we're back for the second talk. Next up, we have Kevin Berendsen, who's a senior software developer at OpenValue. You've spoken at our meetup actually before. It was on a totally different subject, GSR 381, I think.
That's correct.
About well, basically developing artificial intelligence capabilities in Java. That's not what you're going to talk about this evening. Going to talk about a really interesting product, I think, Tekton CI/CD. So really curious what you have to say, and take it away, please.
Yes, thank you. Welcome back, everybody. Thanks for the introduction, Roy. Yeah, today I'm going to talk about Tekton CI/CD, what it is, and why we chose to use it in a project. So for one of the clients, I joined in a completely new team with one other guy, and a month later, we were supposed to get 3 more developers in the team. So we had a month to create a foundation to start developing service and applications. So we, like I said, we had no legacy, we had no older products that we had to maintain, and we're pretty much got time for ourselves to look into the new stuff. Yeah, we had a couple of constraints from the solution architect that we had to run on OpenShift, pretty much all the services, and stick to the company's tech stack as much as possible. But if we could convince the solution architect otherwise, then we were good to go as well. So the same goes for our CI/CD solution. Most of the teams, all the teams, were using Jenkins, and they were all provisioning them on Kubernetes, well, on OpenShift. And there was a bit of a hassle with upgrading, stuff like that. So the maintenance was a major pain in the ass. Well, so one of the architects hinted us, well, maybe Tekton CI/CD is a very nice solution, because OpenShift integrates Tekton CI/CD as OpenShift pipelines really easily. So it was already installed on the cluster, and we were just able to use it. So what Tekton is really all about. So it's a CI/CD solution on top of Kubernetes, and pretty much running all the tasks in containers. So it leverages your Kubernetes cluster or your OpenShift cluster. All the pipelines are defined in YAML. So when you're used to creating resources in Kubernetes, you're pretty familiar with creating resources for Tekton. As a developer, there was almost no maintenance. So looking at a comparison between Tekton and Jenkins, well, like I said, we had almost no maintenance because Tekton was already there, and the cluster administrators, yeah, they were pretty much maintaining it. So if there was a new version of OpenShift, they were also installing a new version of Tekton. So there was, yeah, so there was no issue there. Same type of definition as Kubernetes resources. So if you're familiar with curating Kubernetes resources, then you're pretty much up to speed real fast with creating your pipelines in Tekton. And the reuse of Kubernetes resources is also a very strong pro for using Tekton, because if you create a secret, for example, or configuration map, then you can really easily integrate that in your pipeline. And I also kind of show that later. And also in the demonstration that I created, did the very same thing. Yeah, well, as far as Jenkins goes, pretty much every developer once encountered using Jenkins, and all developers at that company in the business unit were familiar with the setups, knew how to use Jenkins. So there was very familiar with those guys. And there was much more knowledge on how to build pipelines in Jenkins in the business unit, and there was almost no experience using Tekton. So that was a really downside for using Tekton. So if we were stuck, we were pretty much left to the open source community for help. Luckily, we were able to figure out almost anything with the documentation that Tekton created. So there was a really big plus at the end. And yeah, what we could do is just copy paste another team setup and hopefully it will run well. So copying the deployments and stuff like that. Yeah, coming back to Kubernetes, if you're not really familiar with Kubernetes, this is an example definition. At the top in orange, yeah, you pretty much see the API that you're using. In green is the kind of resource that you're trying to create. In cyan, you see some sort of metadata, which is very important, for example, the name. And then in the white, you pretty much specify the resource. So the attributes that belong to the resource you're trying to create. And in this example, is a deployment. And so that's going to be really similar to what we're going to do with Tekton. So what you really want to do is in your CI/CD solution, you want to execute tasks, and a task can contain multiple steps. And because we are leveraging Kubernetes, every task that you define runs into a separate pod, and every step that that is defined runs in a separate container inside that pod. And you can pretty much use any image, Docker image that you would like for those steps. And there are many tasks that are already open for you to download and install on your Kubernetes namespace. So in this example, we've got a Maven task that has two steps. One, to properly set the Maven settings so that your Maven setting is set up correctly for your Maven goals to be executed. So a Maven goal could be running clean, and then a package to create a jar for your Java application. So what the task looks like is pretty much like this. So this is tasks are not really something that you create often, but you could be, because there are already many tasks that you can already download from the open source community. But just give you an example on what it looks like. So at the top, again, we define the API and the resource that we are trying to create. The metadata, which is really important because we define the name here, and then eventually the specification. Well, the specification contains a description, which is optional, but it could be very useful for someone else to use it if it's very complicating. The workspaces, I will elaborate a bit more on that. A workspace could be something that you share input and output with other tasks and pipelines. And there are different types of workspaces that you can define. For example, persistent volumes, which is something that's used often, for example, to check out source code from GitHub. And then in the next task, you run your Maven task to compile it or create a jar for it. You can include secrets, configuration maps, or pretty much any other type of storage that you have available in Kubernetes. So when we look at the workspaces in the task definition, we don't specify yet what kind of workspace it is. We just define, okay, we need a workspace. For example, we need a workspace for source, and we also want to have a workspace for Maven settings. So we create multiple workspaces. Again, we can create a description, but again, it's optional. Next will be the parameters, which is also optional. You don't have to define parameters, but in this example, we have a parameter called goals and a context directory where the project is in. Again, descriptions. The type of parameter, you can have different types. For goals, you can have, like I said, you can have multiple goals that you want to include during execution. By default, You can also create define a default value. In this case, it's just package. So if there's no default, it's mandatory to fill in the parameter on runtime, and if there's none, then I mean, if there's a default, then you don't have to define it on runtime. But yeah. And then next, the steps. Like I already said, we have Maven settings to set up your the Maven settings correctly in your in a certain workspace. And we have got Maven goals where we execute the Maven goals that you specified. In tasks, it's very important to configure these steps or define these steps in the order that you want to execute them. It's not possible to run them in parallel. For pipelines, it's something different, but I will get to that later. Then again, you can have images. You can set up an image. In this case, we have different images for those different steps, which will also create separate containers for it. And then again, the execution of the actual step. I won't go into much detail of these, but if you look closely already, you can see that we are using the parameters and the workspaces that's defined in the task to create the flexibility to execute different goals on runtime if you define the runtime task multiple times. Well, executing just one task is not really a pipeline, and like I already mentioned, you can have, for example, a task to check out code and a task to build your code and maybe even deploy your code or whatever. And we actually want to do that as well. So in Jenkins, we always do that, or any other CI/CD solution. And Tekton is not really any different. So a pipeline is used to combine tasks together, and a pipeline is pretty much a collection of tasks. And in the pipeline, we are referring to an existing task. So we don't define the actual task, but we're referring to a task. Well, hey, we want to, for example, start using Maven. And a pipeline could look like this. So at first, we want to check out the code. Then we want to run, for example, Maven build or compile. Then maybe do some quality checks, deploy the code, and then notify maybe on Slack, well, hey, the build failed or the build succeeded. And if you look at this, for example, if the deployment fails, you won't get notified in this scenario. So they come up with something like a finally block, where if anything happens during the pipeline, whatever is defined and finally, it gets executed as well. And also got the demonstration of that, where we have multiple notifications depending on whatever goes right and whatever goes wrong in the pipeline. And what good is that if a pipeline is only able to execute tasks in sequential order, you can also run tasks in parallel. By default, Tekton actually runs everything in parallel unless you specify otherwise. So in this example, we could perhaps create a Docker image while we are doing the quality checks. I mean, why not? It really, for example, if the creation of the Docker image only lasts 4 seconds and a sonar needs 5 seconds, then you won't notice the difference when we are creating the Docker image. So the duration of the pipeline execution stays the same. So coming to the pipeline specification, it's very similar again to the task specification, but the slight difference is here. Again, we specify the API, the kind. In this case, it's a pipeline, and we call the pipeline Hello World Service because we are building Hello World Service. And we want to deploy this pipeline in OpenValue Ops. This is a different namespace And we have also a namespace for applications that we're gonna deploy to. So we're gonna show you that in a bit as well. Coming to this actual specification, we can define parameters similarly to whatever you have, whatever you do for tasks. So in this case, I define a branch that I want to check out. I want to check out with Git. Then I have a section where I can define the task. Here what you can already see is that I'm using a task reference to a kind task, and git clone, which is the sole purpose of only checking out the repository. And then, well, you can have multiple tasks, but I will show you that. I will show you that later in an example. But yeah. And then we've got workspaces again. You don't define yet what kind of workspace it is. You just define there's a workspace that you would like to use. Usually in the pipeline, you define a workspace and then you just pass it along to a task. So that's really the same goes for parameters really in a pipeline. So it's just passing along, just similar as you would have with a Java class, where you only pass the parameters that you receive from a class or from an input to another from another class. So what does a task reference in a pipeline look like? Because the screen was was too small for it to show it on in the previous example, but here we have Maven build. We call it Maven build, where we just where we refer to the task Maven, and we're gonna run it after the fetch repo task. So this is the part run after, where you define, well, we wanted to run it in sequence rather than parallel. Then we set the parameters. For example, in this case, we skip the test. At least we set the parameter to skip a test. We clean it and then we package it. And then, as you see for the workspaces, in the previous example here, we have workspace, shared workspace, and Maven settings. And here we just pass them along to the tasks. So for our pipeline, that we're gonna create. So it's slightly bigger than I show on the slides. But here we define multiple parameters, one for the git commit hash, one for the branch that we use later. Then we have the fetch repo task, where we check out a certain repository, and where we check out by branch. We set the workspaces, so that's not really that difficult. We built a project with Maven, which is a very simple Java application, by the way. We use Spring Boot and we Dockerize it later, where we say create image after building. We're skipping the whole Sona stuff because that's gonna take too long. We're just gonna create an image, and where we use a Docker file that's simply basic. We're just using an OpenJDK version from Azure, and then it uploads it to a certain repository. So this is a Docker registry. Sorry. So we are uploading it to a Docker registry, and then later on we deploy it using Helm. Helm is just a tool for which has some templating, where we make deployments of Kubernetes resources really easily. As you can see in the parameters, we deploy it as Hello World service in a different namespace than where the pipeline lives. And then finally, we notify if the build failed. So we get a Slack message if the build failed on a certain branch with a certain commit. We get a notification if the deployment fails. And then if it succeeds, then we get a successful message that is deployed successfully. And at the end, we are defining the workspaces. Like I already mentioned, that the workspaces can be different. For example, and when creating the image, we also want to upload it. And this, so we need to provide some sort of credentials for Google Cloud Platform because I'm hosting the Kubernetes cluster on Google Cloud Platform. We also need to pass along the credentials. So if you look at the runtime, at the pipeline run, where it actually, which is a resource that you create to run a pipeline. It's really small, but where you can see, okay, we're gonna create a pipeline run resource and in the same namespace. And then there's something different here. For other resources, you usually specify name, but because this is a resource that we create frequently, we just want to generate a name, because otherwise, every time we want to create this resource, we have to define our names ourselves, and well, that's maybe not something that you want to do or create a hash yourself. The platform already handles that for you. When looking at the specification, we're referring to a pipeline similar as you would when you're referring to a task. We set the parameters. So this is the moment where we set the parameters correctly. Well, this is the git commit hash, the branch name that we're just setting. And this is the, like I mentioned, where you can specify the different types of workspaces. So for Maven settings, well, we're not downloading dependencies from a special artifactory where we have to pass along the credentials to or something else. So we can just define, well, the Maven settings is just an empty directory and you don't do anything with it. But you have to specify it because otherwise it breaks. There's no default workspace, so that's one of the downsides. The shared workspace is pretty much where we check out the code, build the code. And so this is something that we want to be able to allow tasks to write to. So we create some sort of persistent volume to be able to do that. So we are leveraging the Kubernetes platform to write storage to. And then in the end, we say, all right, the Google Cloud Platform credentials, we want to read that from a secret. So we're using an existing secret that are uploaded to the namespace, to use that in the pipeline. The majority of the workspace types are read-only, except for persistent volumes and some other types. But the persistent volumes is pretty much a type that you would use frequently. So then we have defined a pipeline. We don't want to trigger the pipeline manually every time by hand or running a CLI script. We want to do it automatically. That's what you would usually do. So for example, if you commit to a certain branch, that it will trigger a pipeline for you. So Tekton created something like an event listener. So an event listener listens to events and allows you to trigger based on certain criteria. So a trigger could have an interceptor where it checks, are you committing to the main branch, then trigger the pipeline, or use these parameters for the pipeline that you want to trigger. So in our scenario, we had multiple triggers for different branches. For example, if you develop on any feature branch, if you commit on any feature branch, it will it will trigger a new pipeline and deploy that version onto a development environment. If you for example, if you merge that feature branch into the develop branch, it will commit to staging. And then for main, it will push to production. That's how we set it up. It's pretty similar to what the other team set up in Jenkins. We wanted to have that pretty much the same. So the transition for other teams, if we want to go to Tekton, the flow doesn't change really that much. So we try to copy that basically. So when looking at the event listener, again, we're starting with the API that we want to use. We're creating an event listener. We name it. And then that comes to the part where we define multiple triggers. We name the trigger main branch, for example. Then you have interceptors. I don't go really specifically, I don't really dive deep into the interceptors because they can be quite complicating sometimes. But that's where you configure it, and there are many examples on how to configure your interceptors. Then you have bindings, and bindings are pretty much parameters that you pass along to your pipeline run. So the bindings that you define here pretty much passed on to the template that you see below. And there are two types of bindings. You can create a resource for it, where you create a trigger binding. That's mostly useful for bindings that are the same for many other pipelines. Otherwise, I would just inline it, because the overview is you keep everything together in the single resource, in the event listener resource, and so there's less magic happening there. Same goes, for example, if you use many abstraction layers in Java. That can also be very complicating for where does this value come from, or where does this method come from, or where does it override this method. Same goes for here. And the trigger binding looks pretty much very similar to just the bindings. You just configure the parameters. In this case, we have a parameter called hello and the value world. Not really rocket science there. And then we define the template. I always try to stick to creating a trigger template resource, because the trigger templates tend to be also really big. So it looks very similar to a pipeline run, but it adds more configuration to it. So that's why I try to usually refer to as existing. And I can show you. Oh,
these event listeners are assumed quite specific for the Git provider you use, right? GitHub, GitLab. Is it like implemented specifically for these platforms? Or?
The interceptors, they so the question was that about the interceptors, are they specific for different Git repository platforms? For example, GitHub has their own interceptor than any other Git platform really. So that's true. But we're hosting code on GitHub, and for us it wasn't much of a problem. It was 3 lines of code, and we were good to go. We also had interceptors where we extract certain names from the branch name, so it tended to become a little bit bigger. But yeah, that's true. Looking at the trigger template, we defined the trigger template here. Specification, parameters. So these parameters, they need to correspond to the trigger bindings that you define in your event listener. So they need to be the same. And then you can define resource templates. Resource templates are pretty much resources that will be created when the trigger template is running. You can define multiple, but in our use case, we're only creating one, and we are creating a pipeline run for it. And what you can see here specifically is that we are passing along the trigger template parameters to the pipeline pipeline parameters. And so that's basically what we were doing. So again, it's really about passing along the parameters in the workspaces. So when you've got everything assembled, you've got an event listener with multiple triggers or one trigger, and it creates a pipeline run resource which refers to a pipeline. So for the demo, I'm gonna skip the event listener part. I used to have everything running in OpenShift, but that started crashing locally, so I started using Google Cloud Platform to create a Kubernetes resource, and I didn't really get time to set this up. But we are gonna trigger a pipeline run manually. We're gonna check out, we're gonna also check out the image that's created, and we're gonna also test the application. And so we're gonna test the deployment. So just to check, there are no pipelines yet. I'm using the Tekton CI. It gives you better formatting, better output than if you would use kubectl CLI. But you can use it as well. It's not really mandatory, but it's easier. So there are no pipelines yet. And what we want to do is we want to create the pipeline resource. So here we have got the pipeline resource that we want to create. So that I was showing you earlier. And I'm just going to execute it. Takes a couple of seconds. And here it says that it has been created. So if we run the Tekton pipelines command again, it will show that the Hello World service pipeline has been created 8 seconds ago. Also want to check what the pipeline contains. So we describe it, Hello World service. And then here it shows you in the output pretty much the stuff that you defined in the pipeline. Here also you can see the different tasks that we defined in the different workspaces. And at the bottom you can also have an overview of the previous run pipeline runs. So that's what we're gonna do next. But first we're gonna see if there are any Docker images that are already created in the repository. So here I'm using Google Cloud Artifact Registry, where I host my Docker images. I list the images, and it shows no items, 0 items for any image at all. So also gonna check, are there any pods running on OpenValue production? There are no resources found in the OpenValue production namespace. So we're gonna create, so there's a difference there. So if you wanna create you have to create a pipeline run instead of applying a pipeline run if you use generate name in the metadata. So here we go, pipeline run. It has created the pipeline run. We're gonna check that out using the Tekton CLI pipeline run OpenValue ops list. Here we see that we've got one running. I'll also want to check it out, how it's doing, what's doing so far. So it already succeeded in fetching the repository. You can also see the workspaces that I bind to the defined workspace is the value that you use as parameters. So pretty nice tool to see how your pipeline is going, how it's doing. Gonna wait a couple of seconds more. Takes about a minute or two to complete.
I have a question. While
Yes?
you're waiting, can you also show the UI console?
Yeah, Kubernetes doesn't have one, but not by default. But Tekton does have a pod called dashboard, but you have to install it separately, where you can have basically the same functionality as you would have in OpenShift. But I can show you OpenShift the OpenShift pipelines later. Now, so here it has created the image already. So we're gonna check that out. If it's there in the registry, here we can see we just created one at this time. And I got a notification on Slack. It's pretty small, but it here says that he deployed the master branch successfully. So we got a Slack notification there. So we're gonna check out production. And we've got a single pod running there. Let's just port forward so we can test the application. I would have to create a second tab. Which port was I using? It shows Hello World, because I just created a Hello World application with a Hello World resource. So let's just say that we want to change the output. Just say hello OpenValue meetup. Gonna save it. Gonna close this one. Gotta commit it. Yeah, well, I need the hash. I'm gonna copy that, gonna change that in the pipeline run. There we go. Oh. I think that was it, right? Yes, that was it. And now if we gonna create another pipeline run, list it while it's running. In the meantime, I can look up OpenShift pipelines. Documentation doesn't really show it yet. Maybe UI. But there you can see it has a very nice overview of the pipelines and also the last run. So that's very similar to what you would have at the CLI, but it's a little different. Then you have an overview of pipeline runs. Yeah, it looks really nice. You can also start a pipeline run from this UI. You get a nice details overview of the task that is executing. Yeah, really basically everything that you would have in a CLI, but then in a UI. Should be almost done. Oh yeah, I will get a notification soon. The second notification just came in on my Slack channel. I'm gonna check it out if the new pod has been created. The age of 33 seconds, so I'm just gonna assume yes. Gonna port forward it again. And when I curl the statement, we get the new response from the application. So that was a really basic example that you can really easily create your pipeline in a single definition and trigger it very easily with really basic stuff, and then pretty much everything that you would also have in Jenkins, well, the majority of in this demo. So that was pretty much it. So first of all, thank you for watching.
Right, let's hear it again. Before we start with the questions, Kevin, here's also to you. Thank you.
Thank you very much.
Enjoy it. So it's amazing how far we've come with software development from maybe in the 90s, copy and pasting code to Word documents to keep track of it, using source control, using continuous integration, CI/CD, and now with Kubernetes and these really fancy tooling. It's pretty awesome. It was a really nice overview, Kevin. Does anyone have a question at this moment to Kevin? Yes, please.
What is the binary to go from Jenkins to Tekton?
Well, we didn't.
Repeat for the
Oh, sorry. Yeah. So the question is, what was the time needed to go from Jenkins to Tekton? Well, for us it was none, because we're a new team. We had no legacy. We didn't have Jenkins service yet. So for us it was pretty easy. But from another OpenValue colleague who's transitioning, I don't know how long it took for him, but yeah, it will take time. You usually have both solutions running at the same time in the beginning, but yeah, for them it's very convenient to start using Tekton rather than Jenkins. But yeah, the answer for your question, I don't know.
I think the most steps are the same, but it's a different structure. You have to get used to that. It didn't take a long time because most people are mainly used to Jenkins.
So the question was that the structure for Jenkins is differently than to Tekton. Yeah. Well, I use various CI/CD solutions. I also use GitHub Actions. Recently used Azure DevOps pipelines. So wasn't really much of getting used to. The basic principles are pretty much the same. You just have to get used to the syntax. What I do know is that for the people that were using in Jenkins, you also have some sort of pipeline definitions in a single file or something similar. Look pretty much the same, except just a different syntax. Maybe just some fine tuning. For example, we used Canico as a solution to create images, but in Jenkins you use a different solution to create Docker images and upload that. So that was I think that was the biggest issue there for us to figure out. Yeah, that was pretty much it.
Any other questions at this moment? don't think so. So again, Kevin, thank you.
Yeah, thanks.
So with the end of the second talk, we also come to the end of this meetup for the people online. And for people right here, there's another good part that's still up and coming. We're gonna have some drinks together, if you like. So let's start with that. And people online, hope to see you next time. And people here, let's have a drink.